Assalamu alaikum dear students. In the previous class we have actually discussed the scalar or dot product of two vectors when vectors are represented in terms of their rectangular components. So if we have two vectors v1 and v2 represented in terms of their rectangular components, then their dot product that we have calculated in the previous class is equal to the sum of products of their corresponding rectangular components. That is, if we have vectors v1 and v2 as a1i plus a2j plus a3k and v2 as b1i plus b2j plus b3k, then their dot product is directly equal to a1b1 plus a2b2 plus a3b3. That is sum of products of their scalar components or sum of products of their corresponding rectangular components that we have discussed in the previous class. And in the previous class we have also discussed the condition for perpendicularity of two vectors. We know that two non-zero vectors are perpendicular if and only if their dot product v1 dot v2 is equal to 0. So if the dot product of two non-zero vectors, if the dot product of two proper vectors is equal to 0, that is dot product in terms of rectangular components is a1b1 plus a2b2 plus a3b3. So when a1b1 plus a2b2 plus a3b3 is equal to 0, obviously vectors must be perpendicular to each other. So in the questions we may have asked there, that is we have two given vectors v1 and v2 expressed in terms of their rectangular components, and we have to check whether they are perpendicular or not. At that time, when vectors are expressed in terms of their components, you need not find the angle between them. No. So if the angle is 90, you can say that vectors are perpendicular. No, you cannot. You have to approach. That is, you have to find their dot product v1 dot v2 in terms of their rectangular components. If that comes out to be 0, vectors must be perpendicular. If that is any other scalar, positive or negative, then the dot product, then the vectors must not be perpendicular. They may be inclined with some different angle other than 90. So that was the topic that we have discussed in the previous class. Now, in today's class, we are going to discuss another topic, and that's called angle between two vectors. How we can find the angle between two vectors? So how we can find that? Let us start. Let theta be the angle. Let theta 0 is less or equal to theta is less or equal to pi be the angle between two non-zero vectors. Be the angle between two non-zero vectors v1 and v2. So we have two non-zero vectors v1 and v2, and theta 0 is less or equal to theta is less or equal to pi is the angle between them. Means suppose we have these vectors in this form. Suppose this is our vector v1 represented by some directed line segment, and suppose we have our vector v2 like this represented by another directed line segment, and suppose they are inclined at an angle of theta. Suppose the angle between them is theta. So we need to find that theta, we need to find that angle between two proper vectors v1 and v2. How we can find? So we have taken two vectors v1 and v2, two non-zero vectors, and theta is an angle between them. Then we have, or therefore, then we have, here we will use the definition of dot product of two non-zero vectors. And what is the dot product of two non-zero vectors by definition? That is the product of their moduli and cosine of angle between them. So then we have v1 dot v2. v1 dot v2 is equal to the dot product of two non-zero vectors by definition is equal to, yes, product of their moduli, that is magnitude of v1 into magnitude of v2 into cos theta, that is cosine of angle between them, where 0 is less or equal to theta is less or equal to pi. So implies this can be further written as, हाँ जिगरा cos theta को RHS में ही रख दो, ये v1 v2 मैग्नीट्यूड जो स्केलर है इसको यहाँ पे ले आओ तो डिवाइड होगा, वहां पे बचेगा cos theta. So cos theta must be equal to, yes, v1 dot v2 divided by magnitude of vector v1 into magnitude of vector v2. So cos theta must be equal to magnitude of v1 dot v2 divided by magnitude of vector v1 into magnitude of vector v2. This would be the expression for calculating the angle between two vectors in general. When vectors are generally represented, then the angle between them can be written in the form cos theta is equal to v1 dot v2, that is their dot product, divided by magnitude of v1 into magnitude of v2, that is product of their magnitudes. Means the cosine of angle between two non-zero vectors, the cosine of angle between two non-zero vectors is equal to the ratio of their dot product to the product of their magnitudes. Here we can write that is the cosine of angle, that is the cosine of angle between two vectors, non-zero vectors, that is the cosine of angle between two non-zero vectors is equal to the, आजिग्रा किसके बराबर होगा, is equal to the ratio, divide है तो ratio, is equal to the ratio of their dot product, is equal to the ratio of their dot product to the product of their magnitudes, is equal to the ratio of their dot product to the product of their respective magnitudes. So if you have to find the angle between two non-zero vectors, you have to directly find their dot product and divide that dot product by the product of magnitudes of vector v1 and v2 and take it equal to cos theta, and from that cos theta equal to v1 dot v2 divided by magnitude of v1 into magnitude of v2, you can find the angle between two vectors. Now, if these vectors are represented in terms of their rectangular components, means if we have vector v1 which has been expressed as a1i plus a2j plus a3k, and we have vector v2 is equal to b1i plus b2j plus b3k. When vectors are represented in terms of their rectangular components, when vectors are represented in terms of their scalar components, they have been resolved either in plane or in space, then at that time what would be the angle between them? Here we are going to calculate. Now let v1 be a vector which has been expressed as a1i plus a2j plus a3k, and v2 be a vector which has been expressed as b1i plus b2j plus b3k. Then at that time, when two vectors are represented in terms of their rectangular components, at that time what would be the angle between them? How we can calculate that? We will use this expression first. Here we will keep it as first. So in that expression first, we have cos theta is equal to v1 dot v2 divided by magnitude of v1, magnitude of v2. So in order to find the cosine of angle between these two vectors v1 and v2, you need appropriately three things. One is v1 dot v2, and another is magnitude of v1 into magnitude of v2. So you need to calculate three things. First v1 dot v2, after then magnitude of v1, after then magnitude of v2. So therefore firstly we will calculate v1 dot v2, dot product of two vectors v1 and v2 when they are expressed in terms of their rectangular components. Hajigra, when vectors are represented in terms of their rectangular components, what is their dot product? Yes, sum of products of their corresponding scalar components, that is a1 b1 plus a2 b2 plus a3 b3. So v1 dot v2 is a1 b1 plus a2 b2 plus a3 b3, because this thing we have calculated in the previous class, dot product of two vectors in terms of their rectangular components. Now secondly, we need to calculate magnitude of vector v1. Magnitude of a vector when vector has been expressed in terms of components, किसके बराबर होता है? Non-negative square root of sum of squares of its scalar components. So what are the scalar components of v1? a1, a2, a3. So magnitude of v1 is non-negative square root of a1 square plus a2 square plus a3 square. And similarly we can calculate magnitude of vector v2. That will come out to be non-negative square root of sum of squares of scalar components of vector v2. What are that? b1, b2 and b3. So it will come out to be b1 square plus b2 square plus b3 square. Now we have all the three quantities. v1 dot v2, magnitude of v1, magnitude of v2. We will put these three quantities in equation first and we get, therefore from first we have what we have from expression first, equation first, cos theta must be equal to, cos theta is equal to, yes, v1 dot v2 divided by magnitude of vector v1 into magnitude of vector v2, and that will come out to be, what is v1 dot v2? a1 b1. So a1 b1 plus a2 b2 plus a3 b3 divided by magnitude of vector v1, what is that? Non-negative square root of a1 square plus a2 square plus a3 square, and magnitude of vector v2, what is that? Non-negative square root of b1 square plus b2 square plus b3 square. Now cos theta is equal to this thing. From that expression we can find that operating cos inverse on both sides. When we operate cos inverse on both sides, यहाँ पे cos और cos inverse कैंसिल नहीं होता है जिगरा, हमने पढ़ा है इनवर्स ट्राइगोनोमेट्रिक फंक्शन, इसमें ये बन जाती है आइडेंटिटी फंक्शन, और आइडेंटिटी फंक्शन की प्रॉपर्टी होती है कि वो मतलब थीटा को थीटा के साथ ही मैप करेगा, पाई को पाई के साथ, पाई बाय 2 को पाई बाय 2 के साथ, अंडर रेस्ट्रिक्टेड कंडीशंस, दैट्स कॉल्ड रेस्ट्रिक्शन ऑफ डोमेन। वो हमने इनवर्स ट्राइगोनोमेट्रिक फंक्शंस में पढ़ा है। तो जिगरा cos and cos inverse will become an identity function and there will remain what? Theta. So theta must be equal, RHS में क्या आएगा? Cos inverse of theta must be equal to cos inverse of a1 b1 plus a2 b2 plus a3 b3 divided by square root of a1 square plus a2 square plus a3 square into square root of b1 square plus b2 square plus b3 square. This thing, from that expression we can find the angle between two non-zero vectors when they are expressed in terms of their rectangular components. So the angle between two vectors is directly equal when the two vectors are a1i plus a2j plus a3k and b1i plus b2j plus b3k, then their dot product, then the angle between them is directly equal to, yes, theta must be equal to cos inverse of a1 b1 plus a2 b2 plus a3 b3 divided by square root of a1 square plus a2 square plus a3 square into square root of b1 square plus b2 square plus b3 square. That was about the topic angle between two vectors. Now we are on the concept, and that's called direction angles and direction cosines of a vector. Very much important as for your examination and competitive exams are concerned. This is very much important topic, direction angles and direction cosines of a vector. एक वेक्टर के डायरेक्शन एंगल्स क्या होते हैं और उस वेक्टर के डायरेक्शन cosines क्या होते हैं, and how we can calculate these direction cosines of a vector. एक वेक्टर के डायरेक्शन cosines हम कैलकुलेट कैसे करेंगे, तो देखते हैं. If a vector v which is expressed in terms of its components as a1i plus a2j plus a3k. If a vector v is equal to a1i plus a2j plus a3k makes angles alpha, beta and gamma with the positive directions of x-axis, y-axis and z-axis respectively, then alpha, beta and gamma are called its direction angles, and the ordered three tuple cos alpha, cos beta, cos gamma are called the direction cosines, are called the direction cosines of vector v. Very much important topic as far as the concept of vectors is concerned. डायरेक्शन एंगल्स एंड डायरेक्शन कोसाइन्स ऑफ ए वेक्टर. एक वेक्टर के डायरेक्शन एंगल्स क्या होते हैं और एक वेक्टर के डायरेक्शन कोसाइन्स क्या होते हैं. तो क्या होते हैं जिगरा? इफ ए वेक्टर v, अगर आपके पास एक वेक्टर है v which have been resolved, which has been expressed in terms of its components as a1i plus a2j plus a3k, और ये वेक्टर v it must be represented by some directed line segment. और अगर वो डायरेक्टेड लाइन सेगमेंट, अगर वो वेक्टर एंगल्स बना रहा है, मेक्स एंगल्स, कौन कौन से? सपोज अल्फा, बीटा एंड गामा विद द पॉजिटिव डायरेक्शंस ऑफ एक्स एक्सिस, वाई एक्सिस एंड जेड एक्सिस. तो जिगरा अगर आपके पास 3 डायमेंशनल सिस्टम है, सपोज दिस इज योर पॉजिटिव एक्स एक्सिस, दिस इज योर पॉजिटिव वाई एक्सिस एंड दिस इज योर पॉजिटिव जेड एक्सिस. दिस इज पॉजिटिव एक्स एक्सिस, दिस इज पॉजिटिव वाई एक्सिस एंड दिस इज पॉजिटिव जेड एक्सिस. ये पॉजिटिव जेड एक्सिस जिगरा ऐसी नहीं होती है, दे आर परपेंडिकुलर. ऑल द 3 एक्सिस आर म्यूचुअली ऑर्थोगोनल, दे आर म्यूचुअली परपेंडिकुलर टू ईच अदर. ये होती है एक्स एक्सिस, ये होती है वाई एक्सिस, ये जेड एक्सिस ऐसे होती है. ठीक है जिगरा, लेकिन ऐसी लाइन हम बोर्ड पे ड्रा नहीं कर सकते बिकॉज बोर्ड इज एन एग्जांपल ऑफ अ प्लेन. सो दैट इज व्हाई हम इसको ऐसे रख लेते हैं, कंसिडर कर लेते हैं ऐसे. ऐसे ही नहीं होती है, ये ऐसे होती है. ठीक है जिगर. तो सपोज दिस योर पॉजिटिव एक्स एक्सिस, दिस योर पॉजिटिव वाई एक्सिस एंड दिस योर पॉजिटिव z axis, and suppose you have any vector v, you have a vector v, and suppose that vector v makes an angle alpha but with the positive direction of x axis, makes an angle beta with the positive direction of this vector v, makes an angle beta with the positive direction of y axis, and this vector v makes an angle gamma with the positive direction of z axis. So you have to consider a vector in space. You have to consider a vector in space and let that vector v is inclined at an angle of alpha with x axis, is inclined at an angle of beta with y axis, and is inclined at an angle of gamma with the z axis. For instance, if you have 3 mutually perpendicular axes like this, suppose this is your x axis, this is your y axis and this is your z axis. Here lies all the 3 axes. X axis, positive x axis, positive y axis, and here lies the positive z axis. And suppose in between you have a vector like this. आपके पास suppose ऐसे कोई vector, and this vector अगर आपको देखा जाए, ये अगर आप देख लोगे यहाँ पे, तो ये vector v जो है, it makes angles with the positive x axis, it makes an angle with the positive y axis, and it makes an angle with the positive z axis. तो suppose जो ये एंगल बनाता है with the positive x axis, उसको हमने ले लिया है अल्फा. जो ये y के साथ बना रहा है उसको ट्रीट किया बीटा, और जो ये z के साथ बनाता है उसको ट्रीट किया क्या? गामा. और यही अल्फा, बीटा और गामा बनते हैं जिगरा इस वेक्टर v के डायरेक्शन एंगल्स. तो सिंपली अब डायरेक्शन एंगल्स क्या होंगे? The angles which a vector v makes with the positive directions of x axis, y axis and z axis respectively. एक एंगल कौन से एंगल बना रहा है? एक वेक्टर कौन से एंगल बना रहा है with the positive x axis, with the positive y axis and with the positive z axis? उन्हीं एंगल्स को हम कहते हैं उस वेक्टर के डायरेक्शन एंगल्स. एंड द ऑर्डर्ड 3 टपल, अगर आप ऑर्डर्ड 3 टपल ले लोगे, ऑर्डर्ड पेयर और ऑर्डर्ड 3 टपल ये सब कुछ हम पढ़ चुके हैं. ऑर्डर्ड पेयर में 2 ही होते हैं, जब 2 से ज्यादा होंगे तो 3 टपल बनता है, 3 होंगे तो 3 टपल, 4 होंगे तो 4 टपल, 5 होंगे तो 5 टपल, 6 होंगे तो 6 टपल, n नंबर ऑफ आइटम्स होंगे तो n टपल बनता है. तो यहां पे 3 नंबर ऑफ आइटम्स आपके पास है, इसलिए ऑर्डर्ड 3 टपल. ऑर्डर्ड क्यों? क्योंकि पहले अल्फा, बाद में बीटा, बाद में गामा. सो cos अल्फा, ऑर्डर्ड 3 टपल ऑफ cos अल्फा, cos बीटा एंड cos गामा आर कॉल्ड द डायरेक्शन कोसाइन्स ऑफ दैट वेक्टर v. लेकिन ये वेक्टर v जो है that have been expressed as a1i plus a2j plus a3k. तो सिंपल सा टॉपिक है जिगरा, एक वेक्टर v कौन कौन से एंगल बना रहा है, सपोज अल्फा बना रहा है विद पॉजिटिव एक्स एक्सिस, बीटा बना रहा है पॉजिटिव वाई एक्सिस, गामा बना रहा है विद पॉजिटिव जेड एक्सिस, तो वही एंगल्स जो एक वेक्टर बनाता है विद पॉजिटिव एक्स एक्सिस, पॉजिटिव वाई एक्सिस एंड पॉजिटिव जेड एक्सिस आर कॉल्ड द डायरेक्शन एंगल्स ऑफ ए वेक्टर। और उन्हीं एंगल्स के साथ आप ऑपरेट कर दो कोसाइन सीरियली, पहले अल्फा, बाद में बीटा, बाद में गामा। तो अल्फा के साथ ले लो कॉस, कॉस अल्फा, बीटा के साथ ले लो कोसाइन, कॉस बीटा, गामा के साथ ले लो कॉस, कॉस गामा। तो इसी का ऑर्डर 3 टपल जो बनेगा उन्हीं को कहते हैं जिगरा व्हाट, डायरेक्शन कोसाइनस ऑफ ए वेक्टर। सो डायरेक्शन एंगल्स एंड डायरेक्शन कोसाइनस प्रीटी सिंपल सा टॉपिक है। डायरेक्शन एंगल्स हो गए, एक वेक्टर कौन से एंगल बनाता है विद पॉजिटिव एक्स एक्सिस, वाई एक्सिस एंड जेड एक्सिस, फिर उन्हीं 3 एंगल्स के साथ ऑपरेट कर दो आप कॉस, तो कॉस अल्फा, कॉस बीटा एंड कॉस गामा will nothing but be the direction cosines of a vector. Now here we are going to calculate these direction cosines. ये cos alpha किसके बराबर आएगा, cos beta किसके बराबर आएगा और ये cos gamma किसके बराबर आएगा. So here we are going to calculate firstly cos alpha. That's equal. अब ये cos alpha किसके बराबर होगा, अगर इस वेक्टर v को रिप्रेजेंट किया गया हो, एक्सप्रेस किया गया हो इन टर्म्स ऑफ इट्स रेक्टेंगुलर कंपोनेंट्स, तब ये cos alpha जो है फर्स्ट डायरेक्शन कोसाइन जो है ये किसके बराबर आएगा. So that's equal to cos alpha. Cos is cos. What is alpha? Alpha is an angle which the vector v makes with the positive direction of x-axis. But we know that the unit vector along the positive direction of x-axis is taken as I cap. The unit vector along the positive direction of y-axis is taken as j cap. And the unit vector along the positive direction of z-axis is taken as k cap. So, I cap is a unit vector along the positive direction of x-axis, j cap is a unit vector along the positive direction of y-axis, and k cap is a unit vector along the positive direction of z-axis. Now, take a look on this alpha. What is alpha? Alpha is an angle between vector v and positive direction of x-axis, but along the positive direction of x-axis, we have a vector what? I cap. So, alpha would be the angle between vector v and I cap, obviously, because I cap gives us the direction of positive x-axis is a unit vector along the positive direction of x-axis. So, cos alpha के बदले क्या लिखेंगे? Alpha क्या है अब? Angle between v and I cap. So, cos of angle between vector v and unit vector I cap, because I cap is a unit vector along the positive direction of what? X-axis. So that is equal to cosine of angle between v and I cap. या cos को छोड़ो, cosine of angle between two vectors. इससे पहले टॉपिक में पढ़ा था angle between two vectors. cos theta किसके बराबर आया था? v1 dot v2 divided by magnitude of v1 magnitude of v2. That is ratio of their dot product to the product of their magnitudes. तो जिगरा cosine of angle between v भी एक वेक्टर है, I cap भी एक वेक्टर है, तो v और I cap के बीच में cos जो एंगल होगा उसका cosine किसके बराबर आएगा? Their dot product, that is v dot I divided by, yes, product of their magnitudes, that is magnitude of vector v into magnitude of vector I, because previously we have studied about angle between two vectors, and that is given by the expression cos theta is equal to v1 dot v2 divided by magnitude of vector v1 into magnitude of vector v2. And here instead of v1 we have v, and instead of v2 we have unit vector I cap. So that must be equal. v की अपनी definition अपना value put कर दो, क्या है जिगर a1i. So a1i plus a2j plus a3k, इसका डॉट करना है किसके साथ? i के साथ. क्या i के बदले हम ये लिख सकते हैं 1i plus 0j plus 0k? Obviously, क्योंकि i के बदले हमने लिखा 1i plus 0j plus 0k divided by, yes, magnitude of vector v, that is magnitude of vector v into magnitude of I. Magnitude of I, what is I? Unit vector. And what is the magnitude of unit vector? 1. So into 1. And that must be equal to, शाबाश जिगरा, ये भी एक वेक्टर है एक्सप्रेस्ड इन टर्म्स ऑफ इट्स कंपोनेंट्स, ये भी एक वेक्टर है एक्सप्रेस्ड इन टर्म्स ऑफ इट्स कंपोनेंट्स. नाउ यू नीड टू फाइंड देयर डॉट प्रोडक्ट. द डॉट प्रोडक्ट ऑफ टू वेक्टर्स व्हेन दे आर एक्सप्रेस्ड इन टर्म्स ऑफ देयर कंपोनेंट्स किसके बराबर होता है? a1 b1 plus a2 b2 plus a3 b3 sum of products of their corresponding rectangular components. तो इसका पहला कंपोनेंट a1, इसका पहला कंपोनेंट 1, so that is a1 into 1 plus दूसरा कंपोनेंट a2 into उसका दूसरा कंपोनेंट 0 plus a3 into 0, so a3 into 0 divided by magnitude of v1 is our magnitude of vector v. तो implies हमें क्या मिला जिगरा कि cos alpha must be equal to a1 into 1, that is a1, this is 0, this is 0, so cos alpha must be equal to a1 divided by magnitude of vector v. So the first direction cosine of this vector v is nothing else but a1 divided by magnitude of vector v. But what is a1? It is scalar component along the positive direction of x-axis. It is first scalar component. So the first direction cosine of a vector is equal to its first scalar component divided by its magnitude. In the similar fashion, we can calculate its second direction cosine, and that is cos beta. Now, similarly, we can calculate cos beta, and that's equal. Cos is cos. What is beta? Beta is actually an angle between the vector v and positive direction of y-axis. But along the positive direction of y-axis, we have a direction, and that is given by what? J cap. So J cap is a unit vector along the positive direction of what? Y-axis. Means beta would be the angle between vector v and J cap. So cos of beta के बदले क्या लिखेंगे? शाबाश. Angle between vector v and J cap. Angle between vector v and J cap. That's equal to cosine of angle between two vectors. By the previous topic, cosine of angle between two vectors is equal their dot product divided by product of their magnitudes. So v dot j, vector v dot j cap divided by magnitude of vector v into magnitude of j. That's further equal. v का फिर से अपना वैल्यू पुट कर दो, a1i plus a2j प्लस a3k डॉट कर दो j के साथ, लेकिन j के बदले हम लिख सकते हैं शाबाश 0i प्लस 1j प्लस 0k डिवाइडेड बाय magnitude of vector v into magnitude of j. What is that? 1, because j is a unit vector and the magnitude of unit vector is always 1. So that's further equal. शाबाश डॉट प्रोडक्ट कर दो, a1 into 0 0, a2 into 1 a2, a3 into 0 0. तो क्या रहेगा? a2. So a2 divided by magnitude of vector v means cos beta, the second direction cosine of this vector. The second direction cosine of this vector cos beta is equal to a2 divided by mod v. What is a2? It is second scalar component divided by its magnitude. So the first direction cosine cos alpha is a1 by mod v. The second direction cosine cos beta is a2 by mod v. What would be the third direction cosine? a3 by mod v. So similarly, cos gamma, that is the third direction cosine of this vector v, is equal to the third direction, third scalar component a3 divided by magnitude of the vector v. So here we have all the three direction cosines of a vector v. Vector v के तीनों direction cosine जो cos alpha a1 by mod v के बराबर आया, cos beta a2 by mod v के बराबर आया, और cos gamma a3 divided by mod v के बराबर आ रहा है. तो जिगरा अगर आपके पास कोई वेक्टर होगा, इन सिंपल सेंसेस, अगर आपके पास कोई वेक्टर है v इज इक्वल टू a1i प्लस a2j प्लस a3k, और आपको चाहिए इसके डायरेक्शन कोसाइन, क्या आएंगे? cos अल्फा, cos बीटा, cos गामा, ऑर्डर्ड थ्री टपल. लेकिन ऑर्डर्ड थ्री टपल, सो ऑर्डर्ड थ्री टपल ऑफ cos अल्फा, cos बीटा, cos gamma are at its direction cosines, and that can be written as ordered three tuple of what is cos alpha? a1 by mod v. So it is first direction cosine must be a1 by mod v. Second direction cosine must be a2 by mod v. So a2 by mod v. and third direction cosine must be a3 by mod v. So a3 divided by mod of v. Ordered three tuple of this thing would give you the direction cosines of a vector. Means in particular, if you have a vector v is equal to I plus 2j plus 3k, then what would be its direction cosines? It is first direction cosine cos alpha must be equal to first scalar component divided by its mod. What is this first scalar component? 1. So 1 divided by, what would be its magnitude? Square root of, shabash, non-negative square root of sum of squares of its scalar component. So 1 square plus 2 square plus 3 square. कितना आ रहा है जिगरा? 9 plus 4 plus 1. कितने हो गए? 9 plus 1, 10 plus 4, 14. So 1 divided by square root of 14. पहला डायरेक्शन कोसाइन, शाबाश. दूसरा क्या आएगा जिगरा? 2 divided by square root of 14. दूसरा डायरेक्शन कोसाइन. और तीसरा क्या आएगा? 3 divided by square root of 14. इसका तीसरा डायरेक्शन कोसाइन आएगा. So from the vector v, we can directly locate its direction cosines without even seeing its direction angles. डायरेक्शन एंगल्स के बगैर हम निकाल सकते हैं इसके डायरेक्शन कोसाइनस. तो ये था जिगरा टॉपिक, डायरेक्शन एंगल्स एंड डायरेक्शन कोसाइनस ऑफ अ वेक्टर. प्रीटी इंपॉर्टेंट. सो डायरेक्शन एंगल्स क्या हुए? अब द एंगल्स व्हिच अ वेक्टर मेक्स विद द पॉजिटिव डायरेक्शन ऑफ x एक्सिस, y एक्सिस एंड z एक्सिस रेस्पेक्टिवली आर इट इज डायरेक्शन एंगल्स. और उन्हीं डायरेक्शन एंगल्स के साथ ऑपरेट कर दो कोसाइन, फिर उसी का ऑर्डर 3 टपल ले लो और एंड दैट विल गिव यू द डायरेक्शन cosines of that vector. And that's all about the class.